minus 16x. X squared into negative 4x cubed is negative 4x. Back multiplied, negative 4x cubed minus 16x squared minus 20x. Add the opposite. We get x squared. That should leave us with 4x, and that should bring down the 5. And what you'll notice is that's going to go in there the one time. So multiplying it through just to confirm that I got a remainder of 0. I do. Well, what are we going to do with this now? Well, I'm going to set that equal to 0, and what you're going to notice is you cannot factor it. So that would be a dilemma if you were to graph this one. You are not going to see those two zeros at all because they're imaginary zeros. And the two that you're going to get from here, I haven't looked ahead, they're not going to be rational. So if they are real indeed, they're going to have to be some kind of irrational number though, because there's no way to factor that. Okay? My p's and my q's only result in 1, and 1 will never create the 4. So I'm going to go ahead and just, for the heck of it, subtract the 1 over, leave a bit of a space. Half of 4 is 2, 2 squared is 4. I'm going to add 4 to both sides. That factors to x minus 2 squared equals 3. So I know I'm going to have two real zeros, but they're going to be irrational because I'm going to take the square root. I'm going to remember plus or minus, and then I'm going to add the 2 over. Whoops. Apologies. So none of my zeros were actually very nice in that point, but I got to know how to do division of some kind. Okay. Now, what are my complete list of zeros? Well, negative 2 plus or minus I, and 2 plus or minus the square root of 3. How do I write my complete factorization? Well, I'm going to do this as x. Now think of the negative 2 plus I, and bring it back over to make it positive 2. Bring the I back over by minus I. Do the same thing with negative 2 minus I, x plus 2 plus I. Over here, same thing, x, bring over the 2, bring over the positive square root of 3 is negative, and do the same thing, bring over the 2, bring over the minus square root 3. Again, I know you might not want to take the time to, but if you multiply that back out, you will get back to that. All right? Does it make sense, I hope, how these signs occur and to change? Because again, if you know you have a 0, I'll just take one of them for example. To bring it back over, how do you move a minus 2? You plus 2. And how do you move an I back? You subtract it. So what you notice is these are opposite of what those are, and that's how you can easily do that. Okay? So that's just kind of a side note right there. All right? That should give you basically all the ideas that you need for tonight. Maybe that helps you go back to yesterday's or the last week's assignments to clear anything up. It's really important that you know what the number system is, because they throw around terms like find all the rational zeros, find all the real zeros, find all the zeros, which then allow them into the complex numbers. So you really should know those things. What I wanted to finish off with you guys, and I hope this video has been helpful. I apologize, this is the best that I can do. I do miss you guys, and I can't wait to get back to teaching you. But the last thing I want you to do is, if you need to find a polynomial function with, I believe, integer coefficients, okay? So if you're given 5, you're given 1/4, and you're given 1 minus I, well, that appears to be 3 zeros. And I apologize, I should have said that these were some zeros. So initially you might be thinking that you need to come up with a third degree. But you need to remember that these have to occur in conjugate pairs. So if you're given 1 minus I, you need to put in 1 plus I. Okay? So you're actually going to go after a 4th degree polynomial function. Well, first off, this one should be the easiest of them all. If 5 is a 0, x minus 5 is its factor. This is where you have to be careful based off the directions. You have 1/4 here, okay? You do not want to write its factor as x minus 1/4 because that's not an integer. If you FOIL this out, you are going to get fractions which are rational numbers. So you want to write it as 4x minus 1. If you're uncertain how I did that, I'll do a little bit of side work here. Set x equal to 1/4. Just like with most problems, if you have an equation with fractions, you can clear them. So multiply both sides by 4. And then to bring the 1 back, you subtract it. So I hope that makes sense. I'm also going to do a bit of a side work here. I really don't want to write it as x minus 1 plus I and x minus 1 minus I. That's just going to be a little bit too much in my opinion to multiply out. It's doable, but I probably wouldn't write it that way. What I would do again is go back to saying x equals 1 plus or minus I. Bring the 1 back so that you can square both sides to eliminate the imaginary unit I. So squaring out x minus 1. Careful here, I've seen this mistake, is this plus 2 minus 2. It's plus 1 when you square out that 1. And then the square of I is negative 1. Add that back across. So then that's going to be your last one that you're going to put in here. Okay? Minus 2x plus 2. This might not be the prettiest part of the problem, but it's a necessary part. You need to multiply this out so that you have a polynomial function. That is not considered in polynomial form. Okay? Again, you're not going to multiply it all at once, so I would just take the time to do this one. You got 4x squared. Here you're going to get negative 20x. You're also going to get negative 1x, so that's negative 21x. Okay? And negative 5 times negative 1 is positive 5. X squared minus 2x plus 2. Just notationally bring this down so everything is basically secured. Okay? So then after that, what you're going to do